Okay, so who in here has ever wondered where numbers came from? You ever wondered that? Like, how did this get started?
Well, maybe it was pretty easy, and just denied.
Okay, so it says the real number system evolved over time by expanding what the word number meant. At first, number meant something you could count, like how many chickens did the farmer own? Those are natural numbers or counting numbers. If you can count how many chickens you have, that's counting numbers, right? They're called natural numbers like you see on the board. At some time, the idea of zero came to be considered as a number. If a farmer does not have any chickens, then the number of chickens he has is zero. So if we include zero in it, it's a whole number, right? Then it says even more abstract are negative numbers. So say the farmer owed somebody 3 chickens. He would have negative 3 chickens, right? So if we have negative numbers, those are integers. Then once we get more, or if we think about it as a whole, a rational number, it's rational. Then it's any number that can be written as a whole, a natural number, a whole number, an integer, or a fraction, that when you turn it to a decimal, it terminates or repeats. An irrational number is going to be a number that goes on and on and on forever. So we're going to do some examples of them. Okay, so if you have a rational number, let's just talk about rational. Rational number can be your natural numbers, right?
Yeah.
So 1, 2, 3, 4, forever. It's going to be your whole numbers, which is 0, 1, 2, 3, 4. It's going to be your integers, -3, -2, -1, 0, 1, 2, 3, forever, in both directions, right? It's going to be fractions that terminate or repeat. So 3/4, if you turn that to a decimal, is 0.75. Should that terminate? Yes, so it's rational. That's a T for terminate. There you go. 1/3 is 0.3 repeat. It repeated, so it's rational. The square root of 36 is 6, right? 6 times 6 is 36. If it's a perfect square, it's rational. Correct? Irrational numbers, they go on and on forever. For example, 1/7, if you turn it to a decimal, is 0.142857. It goes on forever. Or pi. Pi is 3.14 forever, right? Or the square root of 2. Everybody open up your calculator. And on your calculator, you have a little blue button at the top that says second. It's on the top left. Hit that second button, and then hit your x squared button. And it's going to show you the square root sign. It's going to pop up, and it's going to look like this. Hit 2, and then be sure you close your parenthesis. And tell me what the square root of 2 is.
1.414313562.
It goes on forever. It's not a perfect square, so it would be irrational. And you notice how when we did that, we closed our parenthesis around that on our calculator. We're telling the calculator we just want the square root of this number. So be sure that if you use your calculator for square root, you close your parenthesis. Other questions on this? Say they give you an irrational number like the first number here, and a rational number that terminated like the second one, and they want you to compare them. Well, when you look at it, it looks like they're both 0.17, correct? You always want to round it to the hundredth place. So 6 rounds the 7 to a what? So which one's bigger? Yep. Each your bigger number, 0.18. If it wants you to compare these two, you always round it to the hundredth place. Can 3 round the 4?
No.
So you have 1.54. 1.55. Always use your bigger number. You want to round. If it gives you an irrational number, round it to the hundredth place. Okay, so all numbers, every single number has a place on a number line, right? So let's, I don't know why I did that. Let's say that here's 0, here's 0.5, here's 1, here's 1.5, and it wants you to put 0.1111, it's repeating on a number line. So what do we do with repeating decimals? We what?
Round.
We round them. So can 1 round to 1?
No.
So this would be 0.11. It's repeating, but it would be 0.11. So if you look at it, you put zeros back behind it so they all have the same amount of numbers on the number line. 11, is it going to go before 50 or after 50? So 0.11 would go there, correct? No matter what numbers they give you, any number can be put on a number line. If it gives you a long, crazy decimal, round it. Okay, it's really important to memorize. Irrational plus irrational, always and forever will give you irrational. Irrational times irrational, always and forever will give you irrational. It's called a closed system because it always happens. Always going to give you irrational. An open system is going to be an irrational plus an irrational. Sometimes gives you rational, sometimes gives you irrational. An irrational times an irrational, sometimes gives you rational, sometimes gives you irrational. Okay, if you take the two and you add them together, or you take the two and you multiply them together, one rational, one irrational, it's always going to be irrational, unless it's 0. This excludes 0 in this rule, because an irrational plus 0, well, I guess that would be an irrational too, but it says it's got to exclude 0. It's this system called open or closed that always happens.
Close.
Closed. This is a closed system, because it always happens. Okay, they're all real numbers, right? So if I say the number 10, I wanted you to classify for it, which this is something you're going to have to do on your benchmark test in 3 weeks. So the number 10, it would fit in right here with natural numbers, right? It's a counting number. Would it fit in with whole numbers?
No.
Yes, because it includes 0 and counts all the way up. Is it an integer?
Yes.
Yes. Is it a rational number?
Mm,
Yes. And it would be a real number. So the number 10, you would say it's a natural number because it fits here. If it fits here, it fits in all these other categories. So natural, whole, integer, rational, and real. Does that make sense? How about negative 125? Negative 125, is that a natural counting number?
No, that's an integer.
Is it a whole number?
No.
No. Is it an integer?
Yes.
So it would be an integer. It would be a rational number. And it would be a real number, because they're all real numbers. So if it starts in this category, then it would go up to the next one also. If it starts here, natural, it's natural, whole, integer, rational, real. If it's a whole number, it would be whole, integer, rational, real. If it's just an integer, it would be integer, rational, real. If it's just a rational number, it would be rational and real. Does that make sense how it goes? So if I look at the square root of 2, the square root of 2 goes on forever. So it would be irrational and what else? What?
Real.
Real. It would be irrational and real, because they're all real.
So no matter what the
They're always, because it's a real number, right? A number is a real number, no matter how you put it. It's a real number. If it's irrational, it's irrational and real. And if it starts in natural, you go all the way up. Does that make sense? You will have to do this. It will give you on your benchmark different numbers, and you're going to have to categorize them on where they fall. this would be something really good to memorize.